let's talk about composite functions. F of g of x, this O is of f of g of x or f of g of x, this is another way of writing it, are composite functions. This means a function inside of another function. For example, find f of g of x. This is equivalent to this when g of x is inside f. All you do is replace the x with that function. So f of x is x cubed plus x, and g of x is sine x. All you do is replace that. So f of g of x would be equal to sine x cubed plus sine x. So the sine x becomes the x. So, however, there are some domain restrictions that come with this. For example, because the output of g of x becomes the domain of f of x, the domain of f of x is actually restricted now. So the domain, when we find the domain of f of g of x, when we find a domain, we would actually find a range of g of x. So the range of g of x is, well, it's sine x, so it should be from 1 to -1. So range of g of x. Now that means domain of f of g of x is equivalent to, well, this should be equal 1 between 1 and -1. That is the domain of f of g of x, because the range of g of x becomes the domain of f of x. And to find a range of this, there's really only one way to find range, and that's by graphing it. So that should be your range. Let's take a look at this example. It's another common example for composite functions. It says, use a table to find f of g of x. F of g of 3. So we don't know the functions, but we know what g of x gives you, and we know what f of x gives you. So let's take a look at this. So this really just means f of g of 3. Well, we know g of 3 is equal to 1, so this would be f of 1. And we know that f of 1 from this table gives you 5. So this answer would be 5. That's a very common composite function question. Okay, let's talk about inverse functions. f-1x is the inverse of f of x. So to find the inverse function, you have to swap y and x and solve for y. So for example, find the inverse of y equals x squared. This would be x equals y squared, and that would be square root of x is equal to y plus minus. However, there are some domain restrictions. We know that a function has to be one-to-one. That's the definition of a function, a well-defined function. Now, however, if you graph this, you will realize that this function is not one-to-one. This means we need some domain restrictions for this function. So either we keep one of this, or we keep the other one. To do that, we actually have to set some domain restrictions on the original function. So we would say something like y equals x squared, where x is greater than or equal to 0, or x is greater than or equal to, less than or equal to 0. That's this proper way to define inverse function. You have to do this when you define inverse functions that are not one-to-one. You have to set domain restrictions such that the inverse function will be one-to-one. Okay, and lastly, there are some properties you need to know for inverse functions. So an identity function is when its inverse function is equal to the original function. That's called an identity function. Examples of this is, for example, 1 over x. That is an identity function. And another thing that you should know is that the inverse of its original function, if you have a composite function of that, that would just equal to x. So these two cancels out, and it just becomes x. That's an important property you should know, as you might have questions where they ask you to verify whether a function is its inverse, and you would have to use this property.